Suppose you had the equation of a quadratic that had already been factored. So something like y equals, oh, I don't know, x minus 5 and x plus 3. Those are called factors. Where does that quadratic hit the x-axis? 5 and negative 3. And we find those by setting each factor equal to 0. X minus 5 equals 0, so I need to move the 5 to the other side. I use addition. Plus 5. So x equals 5, and I do the same thing on the other side, and I get x equals negative 3. All that tells me is where the quadratic hits the x-axis. So negative 3 and 5. How many parabolas are there that hit those 2 points? How many different parabolas could you draw that hit both of those? A lot. We could draw this one. We could make one that's upside down. We could make one that's really short. We can make one that's really tall. There are an infinite number of parabolas that hit that set of roots. And it all depends on A. It all depends on this number out here. So this is a regular opening parabola because A is 1. If A was 2, it would be taller. If A was 8, it would be a lot taller. If A was 1/3, it would be a lot shorter. So we're going to graph parabolas given the roots, and it's actually pretty easy. All you need to do is figure out where is the axis of symmetry. Where is the line that cuts the parabola in half? Any idea where that's going to be? X equals... How would you find it? How do I know where the axis of symmetry is? Any ideas? We need to figure out where the minimum or the maximum is. In this case, it has a minimum because the parabola opens up. But in order to find that point, I need to figure out where this line goes. And it's actually really simple. The axis of symmetry cuts the parabola into 2 identical pieces, so this line will always be right in the middle. It will be halfway between the 2 roots. All you need to do is take this number plus this number and divide it by 2. What is 5 plus negative 3? 2, and cut that in half, 1. The axis of symmetry is right here at x equals 1. So the axis of symmetry is x equals 1. And you'll notice that's exactly halfway between the 2 roots. If I count over 1, 2, 3, 4, and 1, 2, 3, 4, it landed right in the middle. All right? Now I know that the vertex is at 1 comma something. How do I figure out what the y value is? Anytime you have an x value, it's really easy to find the y value. Just plug x into the equation. We need to put 1 in here and in here. What is 1 minus 5? Negative 4 times 1 plus 3 is 4. And negative 4 times 4 is negative 16. That is the graph of the parabola. That's pretty simple, right? Excuse me. Let's try another one. Y equals negative 2 times x plus 1 times x plus 3. What are the roots? X equals negative 1 and x equals negative 3. Draw my graph. Negative 1 is one of the roots. Negative 3. What is the axis of symmetry? -2. It has to be halfway between -1 and -3. So the A of S is x equals -2. I know that this cuts the parabola in half. Does this parabola open up or down? Down. How can you tell? The -2. Yes, Corby? No, it's A. A tells us how tall or short the parabola is, and it's not the axis of symmetry. In this case, it just happened to be. But that's not always. Oh, it was in the last one, huh? Oh, yeah. That's not true. But the axis of symmetry is always the x value of the vertex. So I now take -2 and I put it in here and in here. And I get -2 times, what is -2 plus 1? -1. What is -2 plus 3? +1. My vertex, the y coordinate of my vertex is -2 times -1 times 1, which is 2. I go up to 2, and that's what the parabola looks like. All right? Y equals 1/4 times x minus 5 times x plus 1. No, let's not do that. Let's do x plus 2. That'll be a little bit harder. What sort of parabola do we have here? A very short parabola. It's 4 times shorter than you're used to, or 1/4 as tall. My roots are x equals 5 and x equals -2. -2 and 5. We know this parabola opens up. How do I find the axis of symmetry? We add the roots together. What is 5 minus 2? 3, and then we divide that by 2, 1.5. Or 3 divided by 2 is 1.5. So 1.5, right here. That is the axis of symmetry. It's also the x-coordinate of the vertex. Right? Now I need to plug 1.5 into the equation and figure out where the y value is. So 1 divided by 4 times 1.5 minus 5 times 1.5 plus 2. Oh, I missed a parenthesis. Sorry. Ah. There we go. And I get -3.06. So -3.06. The graph is going to go right 1.5 and down 1, 2, 3, and just a little bit. Does that make sense? So you use the roots to figure out the axis of symmetry. You plug in the axis of symmetry to find the y value, and then you can graph. Okay? But most of the time, the parabola is not going to be given in what's it called? Root form. It's going to be in standard form. If I had x squared minus 6x plus 5, we need to factor that. So we put it in the box. X squared and 5. What's my next step? Multiply those together. X squared times 5 is 5x squared. Now I find the factors of 5 that add to be -6. -1 and -5. I put -1x in one box and -5x in the other. Does it matter which way I put those? No, it's not going to change anything. And then I look at the top row. What do the top two boxes have in common? They have an x, and up here, if I take an x out, I'm left with x. And if I take an x out of this box, I get -1. And then if I take an x out of this box, I get -5. So x minus 1 times x minus 5. Not here today. What are the roots? X equals 1 and x equals 5. Okay. I can draw that on the graph now. 1 and 5. Where is my axis of symmetry? Halfway between 1 and 5. 1 plus 5 is 6. 6 divided by 2 is 3. The axis of symmetry runs right through x equals 3, which means my vertex is 3 comma something. How do I figure out the y value? I plug this back into the original equation. Yeah, you could plug it in here if you want. That's fine. It would depend on the numbers, really. But if you like plugging it in down here, we can. 3 minus 1 is 2 times 3 minus 5 is -2. The y value is going to be -4. So I go down 1, 2, 3, 4, and I have my parabola. Does that make sense? Okay, let me look at the book. I think I want to stretch this over 2 days. Let me see if we've done enough. Let's do another one. This one's a little bit strange. If I had 4x squared minus 16x, can I put that in the box? No. So what do? I take a 4x out. Is this a difference of perfect squares? Is it adopts? No. Because it would be 2x and 2x and 4 and -4. But there's an x over there. So this one does not work with adopts. But I can take a 4x out. If I pull a 4x out, what's left? X minus 4. Now, this is one of the roots, and this is one of the roots. What is the first root? 0. And kids get confused on that, and those are the easy ones. If you have an x all by itself, that is a root of 0. The graph is going to go through 0 and x equals 4. Where is the axis of symmetry? At 2. Right here at 2. So 2 comma something. And I take that 2, and I can either plug it in here, or if you prefer, you can plug it in there. 4 times 2 times, what is 2 minus 4? -2. 4 times 2 is 8. 8 times -2, -16. So I go down right to there. Does that make sense? Yeah? All right. What about this? How do you factor that? That one is adopts. What goes in each parenthesis? Uh-oh, I killed it. I don't know why this doesn't... I don't know why this happens so much. If I have 9x squared minus 25, I get 3x minus 5 and 3x plus 5. Okay, the roots will be 5 divided by 3, which is 1.6 repeating, and negative 5 divided by 3, which is negative 1.6 repeating. I put that on the x-axis, 1, 2, so 1.6 would be there, 1, 2, 1.6 would be there. Where is the axis of symmetry? At 0. Halfway between negative 1.6 and positive 1.6 is 0. I put 0 back in the original equation. What is negative 9 times 0? 0 minus 25. So way down here at negative 25. I'm going to run out of room, but clear down there. Does that make sense? Okay, let's do one more. This one's going to be hard to do in my head. Let me see if I can find one. Negative 2x squared minus 4x minus, nope, plus 30. Can I take anything out? What should I take out? Negative 2. Why? We take out a 2 because everything has a 2, but why do I want to bring out a negative? We don't want any negatives on the inside with the x's when we factor. So if the leading coefficient is negative, you need to take out a negative. Taking out a negative 2 is a little bit weird. If I pull out negative 2, what's left? Positive x squared plus, not 4, plus 2x, and then minus 15. Taking out a negative is going to change all of the signs. If you pull a negative away from a negative, you're left with a positive. How do you take a negative out of a positive? It's like saying a positive is 2 negatives, and if I take 1 negative away, then I'm left with a negative. Okay, I put this information in the box, x squared and negative 15. Multiply those together, negative 15x squared. And then I look at the factors of negative 15 and I try to come up with a positive 2. 1 and 15, does that work? 2 doesn't go into 15. 3 and 5, does that work? Yes, as long as the 5 gets the positive. Plus 5x and minus 3x. What do the two terms in the top share? X. If I take an x away from x squared, I'm left with x. If I take an x away from 5x, I get 5. And if I take an x away from negative 3x, I get negative 3. So my formula is negative 2 times x plus 5 times x minus 3. My roots are negative 5 and positive 3. So 1, 2, 3, 1, 2, 3, 4, 5. Where is the axis of symmetry? Well, we plug in, we take negative 5 and 3 and we find the average. Negative 5 plus 3 is negative 2. Cut that in half and you get negative 1. The axis of symmetry is right here at x equals negative 1. So the vertex would be negative 1 comma something. To find that something, I'm going to put negative 1 into the equation. That yields negative 2 times, what is negative 1 plus 5? 4. And what is negative 1 minus 3? Negative 4. Negative 2 times 4 is negative 8. Negative 8 times negative 4 is 32. So 10, 20, 30, 1, 2. Something like that. I missed, but you get the picture. All right, today we're only going to do half of the assignment. So this will be 3.5. And I'm not sure what we're going to do tomorrow, so we're going to label it 3.5. We're going to start at 3. We'll do 3 through 20 all, but we're going to work again on this tomorrow. We'll do the rest of the set tomorrow. All right, 3 through 20 for today, and then we'll keep going tomorrow.